Hey guys, I want to do one example of each one of these from your actual worksheet here. Um, so let me do this one right here. For each of these, in this first case, they say they want you to add up these two vectors, or these two here, and then get the magnitude and direction of your displacement. So the displacement is represented by that arrow right there. So this is easy. It's a 3, 4, 5 triangle, but remember, if it wasn't so easy, it'd be 3 squared plus 4 squared. Square root of that is 5. So boom, we've got our displacement. But now we still need to get our angle. So our directions. What is that angle right there? So when you go to do this, there's several different ways. This time I'm going to do one of our inverse trig functions, and I'm going to say the angle is equal to, this time I'm going to do tangent. So tangent is defined as opposite over adjacent. So 4 over 3 there. So if I plug that into my calculator and do inverse tangent of 4 over 3, it will tell me that the angle is equal to 53 degrees. But we got to be clear, 53 degrees where? From what? 53 degrees relative to what? So if you look here, since this is 53 degrees, we are turning 53 degrees towards the west from the north here. So this is 53 degrees west of north. Or again, like in the other video we talked about, you can start on the east line and just keep rotating. So you'd go 90 here and another 43. So you could just say 143 degrees, and that would be okay. Let's do one of these. So here again, they want you to add them all up and get the magnitude and direction of your displacement. So to add these up, the first thing we need to do is to add up all our east-west and north-souths. So look at this. If I want 7 meters to the east here and 5 meters to the east here, let me just combine that. So that means overall, I want 12 meters to the east. I only have one north-south line here, so just one 5 to the north. But I'm going to draw it like this. So now I have a new triangle that I can build. And so that looks like this. 12 to the east, 5 to the north. Here is the hypotenuse. So do 12 squared plus 5 squared, take the square root. This is actually also a regular triangle. That turns out to be 13 meters. So that's our displacement, 13 meters. But not done yet. We got to find the direction here. So the direction, that tiny little angle right there. So let's do one of these. The angle here is equal to, let me just do the inverse sine here. And I'll do inverse sine is opposite over hypotenuse, so 5 over 13. And if you do that, it will tell you that your angle is about 22.6 degrees. Now in this case, since we're turning from the east line, we can just leave it as that, it's fine. You could also write 22.6 degrees, north of east there. Either one of those would be correct. Let me show you an example of number 3 here. So they want you to resolve these vectors. In other words, they want you to find the sides. So we could call this the horizontal component. Remember, that's what we call a side. And we could call this the vertical component. So how would we find those? We got to use our trig functions here. So to find the adjacent side here, the adjacent side is always the hypotenuse times the cosine of the angle. So 12 meters times cosine of 30. And if you plug that in, you will get 10.4 meters as your adjacent side here. What about this one right here? So this is the opposite to the angle. So that's when we use sine. So the opposite side is equal to the hypotenuse times the sine of the angle there. So in this case, that will be 12 times sine of 30, and that works out to be 6 meters. So this side is 6 meters right there. Let me do one example of number 4, and then that will be it. So here, They want us to add up the 5 meters, the 12 meters at an angle here, and the 4 meters. This is going to involve all of our techniques rolled up into one. So we've got to put all of these together. Before we can add in this 12 meters, we've got to bust it apart. We've got to resolve it into its components, we call it. So let's find its two sides. Now actually, if you pay attention, we just did this one in the previous example. We already found these sides here. So this side turned out to be 6 meters, but we could use our sine function to find that if we hadn't just done it above, because this would be 12 times sine of 30 would give you 6. And we just did this one above. 12 times cosine of 30 gives you 10.4. So now let's pretend like this 12 meters doesn't even exist. And we've got 5 meters and 10.4 meters and 6 meters and 4 meters. So now we can build ourselves a new triangle. This one is 5 plus 10.4 plus 4 to the east. So overall, we've got 19.4 meters to the east there. And then we've only got one north-south here. That's 6. So we've got 6 to the north. So let's combine them together right here. There's our hypotenuse. So I'll leave you guys to do this, because you know how to do this. 19.4 squared plus 6 squared will give you this hypotenuse. And then you should know how to find those angles there as well, and be able to do that.